Advanced Algebra 2 Semester Exam Review, Unit 7, Systems of Equations and Inequalities. So for systems in three variables, you're talking about the 3D plane. So we are talking about if you had something like this. So this was like the floor, and then these are like the walls of the room. And so you're talking about planes intersecting. You're not talking about lines intersecting anymore. So when we're talking about solutions in three variables, there could be one, none, or infinite. If there's one solution, that would be where all three planes are crossing in one designated spot. For no solutions, none of the three planes are crossing at once. So this is only 2 out of the 3, this is 2 out of the 3, and 2 out of the 3. There's not one spot where blue, red, and green are all crossing at the same time. And then when there's infinite solutions, the three planes are crossing here and here and here and infinitely in a line all the way across. So it has more than one intersection point of all three planes. So we can solve these by hand, but we also have the use of a calculator, the TI Inspire as well. So here are our calculator steps, and I will go through those with us, but they are there as well. So what is the solution to the system of equations here? First thing we need to make sure of is that all the equations are in standard form. So remember that standard form is ax plus by plus cz equals d. So all the variables on one side and the constants on the other. So if we look at each of these equations, we have x, y, z, and then equals number, x, y, z equals number, x, y, z equals number. So these are all in standard form. So what we can do is we can go ahead and put that into a matrix. And so we need a 3 by 4. So we have 3 rows, 4 columns. Each column is for a variable and then the equal sign. So we have 8, 2, negative 3, 20. We have 1, negative 5, 4, negative 22, 2, 1, 1, 3. Now for the calculator to solve this for us, we need a reduced row echelon form and then parentheses around that to tell the calculator to solve it. What that's going to do is that's going to put ones in the diagonal for 1x, 1y, 1z, and it's going to put zeros everywhere else that you don't have a 1. That way it gives you just the value for x, just the value for y, just the value for z with no extra information. So all right, so you want to press home, and then if you want to add a calculator. So in order to get that RREF, you can use the keyboard down the bottom, but if you're going to forget what you need to type, you want to press menu, go down to number 7 where it says matrix and vector, and then you want to go to number 5, reduced row echelon form, and press enter. And that will give you your RREF. Now, to get the matrix, you could also do menu, matrix, create, and then matrix. Or if you press the button to the left of the book, that will give you the layouts. And right in the middle is the one that has the matrix of any size. So highlight that, press enter, and then you want to fix your rows and columns. So the number of rows is 3. Press tab. Do not press the down arrow. It will change the number of rows. So press tab. Say 1, 2, 4. There we go. And then you're going to change the number of columns. You're going to press delete and you're going to press 4. And then you're going to press enter for OK. And inside those boxes, you're going to type your numbers. You're going to press 8, tab. Every time you press tab, it'll move you to the right. And then 2, tab, negative 3, tab, 20. And then when you press tab at the end of a row, it brings you to the next one. And just continue to type in your numbers exactly as they are on your paper. When you're done, simply press enter and the resulting matrix is shown. So what that tells you is that 1 in the first row, 1x, no y's, no z's, is 1. So x is equal to 1. In the second row, you have no x's, you have a 1y and no z's. So that means that y is equal to 3. third row, you have 0 x's, 0 y's, 1 z, which is equal to -2. So that is our solution to this system. We have an x value. There we go. We have an x value of, thought I pressed it. Maybe, there it is. 1, 3, -2. So this was the x, this was the y, and this was the z. So let's go ahead and try that for number 15. Now for number 15, we said that all of the equations had to be in standard. The top two, or the first and the middle one, are not in standard. So we need to manipulate them to get them into standard. So let's see, I'm going to rewrite that first equation. 4r is equal to 4s minus 4t plus 14. So in order for this to be standard, your variables must be on the left and your number, your constant, on the right. So we need to move the 4s, and we also need to move 4t. And usually we write them in alphabetical, so RST. So we have 4r minus 4s plus 4t equals to 14. So this one is the new row 1. Now, same kind of idea for the second one. We have 4r is equal to 7 plus 2t. So we're going to subtract 2t from both sides. That will get all of our variables on one side. So now we can make our matrix. So we're going to do r, s, t, and then the equal sign. So for this first equation, we're going to put in 4, 4, -4, 4, 14. For the purple one, we need 4 for the s. Sorry, let's try this again. We need 4 for the r, but 0 for the s, because there are no s's, and then -2 for t, and then 7 for the equal sign. Then the third one was actually in standard form already. It didn't need any fixing. So -3, -3, -4, -5. And then we're going to repeat that same process in our calculator. So again, we want to do menu, matrix, and vector. Matrix and vector. And then we want reduced row echelon form. And then we want to get our matrix with the center. Again, 3 rows, tab, delete, 4 columns, and then enter. And then go type in all of our numbers. -4 and -5, and then press enter. And so in this case, we have, go ahead and write that down. So now we have R of 2, we have S of -1, and T of a half. How the variables come out depends on what order you placed them in. So that's why we always typically say to place them in alphabetical order. Okay, so the next kind of systems are applications. So for this one, you can think of this as like a 2-part problem. One part you have to write the system, and then the next part is solving it. So it takes 2 different pieces. So Billy's Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. Write a system of equations to determine the number of each flower ordered. So my advice is 1, define your variables. So your variables come from the question. It says, write a system of equations to determine the number of each flower ordered. And actually, none of these involve solving. So we no longer need our calculator. We can get rid of that. Okay. So each flower. So we have and it says number of each, so not the value. So the number of carnations, do Y equals the number of roses, and then Z can be the number of daisies. Once you have that, then go look back through your word problem for totals. So let's see, we see that it said the total order came to $589.50. So that's the value. So we need the value attached to each one of these kinds of flowers. So for X carnations, it says that carnations are $1.50. So we have 1.50X plus, and then Y is roses. Those are $5.75. So 5.75Y. Daisies are $2.60, and all of that adds up to 589.50. Then we do have another total. It says that a total of 200 flowers were ordered. So that does not have value attached to them. That's just the number of the flowers that were purchased. And that is exactly our variables. X is the number of carnations, Y is the number of roses, and Z is the number of daisies. So that would simply be X plus Y plus Z equaling out to 200 total flowers. The last one is one that I call a comparison problem. It's probably the most difficult one to write. So they ordered 20 fewer roses than daisies. So because they are comparing roses to the daisies, in order to find the roses, you must know the daisies first. How many is 20 fewer than the daisies? So the number of roses Y will equal the number of daisies, which is Z, and then minus 20. So it always, that middle one is usually the one that's by itself. The last one, or the one that you are comparing to, is the one that has all the math. Twice as many, 20 more than, 20 less than, whatever the case may be. So the one that is compared to has all the math. And this would be our system of equations. Then we do it again for 17. You have 88 coins consisting of quarters, nickels, and pennies. The value of the coins is $6.36. There are twice as many pennies as nickels. Write a system of equations that can be used in this situation. Now, in this case, they're telling you what your variables are, so that makes it even nicer. Q is the number of quarters, N is the number of nickels, and P is the number of pennies. So again, start with totals. So the first total I see is that there are 88 coins. That has nothing to do with value. That is just like me dumping out a jar and counting up the coins. I don't care if they're 10 cents, 5 cents, 25 cents, at 1 cent, it doesn't matter. So we have the number of quarters plus the number of pennies plus the number of nickels, all adding up to 88 coins. Then the second total that we have is the value of the coins is 636. Now this is where you are counting. Okay, all of these ones in this pile are worth 10 cents. All of these ones in this pile are worth 25 cents. Now you care about value. So we know that the value of a quarter is 25 cents. So 0.25 times the number of quarters will give you the value of all of your quarters. Plus pennies is 1 cent, so 0.01p. And then nickels are 5 cents, 0.05, and 0.05 N. And all of those values added together will give you $6.36. The final equation comes from, again, that comparison. There are twice as many pennies as nickels. So again, which one are you comparing to? You're comparing to nickels. So nickels is the one with all the math. Pennies is by itself. So in order to find the pennies, you're going to take the nickels and it's twice. Twice means to multiply by 2, so 2n. And this would be our system of equations for number 17. The last one is what I would consider more of a straightforward type problem. So at a store, Mary pays $34 for 2 pounds of apples, 1 pound of berries, and 4 pounds of cherries. Tom pays $35 for 3 pounds of apples, 2 pounds of berries, 2 pounds of cherries. Lee pays $49 for 5 pounds of apples, 3 pounds of berries, and 2 pounds of cherries. Write a system of equations to determine the price per pound for each item purchased. So let's see. So determine the price per pound for each item. So let's just do X would be the value. So let's see. For 1 pound apple, so each pound. Y would be the value for 1 pound of berries. And Z would be the value of 1 pound of cherries. And this one I consider straightforward because there are three totals. So the three totals we have is what Mary paid, what Tom paid, and then we have what Lee paid. And each of those totals are found by whatever they bought. So for Mary, you're adding 2 pounds of apples, 1 pound of berries, and 4 pounds of cherries. So we have 2 apples, so 2A, plus 1 pound of berries, 1B, plus, I guess this would be LB, not 1. Okay, so 2A, 1B, and then 4 pounds of cherries, and all of those totals add up to $34. Then we have Tom's total, so 3 pounds of apples, 3A, 2 pounds of berries, 2B, and 2 pounds of cherries, 2C, and all of that's going to add up to $35. And then Lee has 5 pounds of apples plus 2 pounds of cherries. Oh, I forgot berries. 5 pounds of apples plus 3 pounds of berries plus 2 pounds of cherries, and all that added up to 49. So it's what I consider basic because they're all totals and they're all almost like you shopping at the grocery store. If this is worth this much money and this much money and this much money, and then you add it all up at the end and get your total. The last part of Unit 7 is the systems of inequalities. So number 18 and 19 is determine if the points below are solutions or not. So just yes or no. So remember that solutions fall in a shaded line and on the, in the shaded area and on the solid line bounding the shaded area. So let's try the first one, 0, 3. So 0 means right nothing and then up 3. So this would be my point. Clearly falls in the shaded area, so yes. The next one would be 3, 0, so we're going right 3 and up nothing. It does fall on the boundary of the shade, but because it falls on a dashed line, it's an automatic not a solution. Negative 3, 5, left 3, up 5 would be here. Now, this one's tricky because it is on the boundary of the shade. It is on a solid line, but because it falls on a dashed line, it automatically makes a no. Anytime you have a point that sits on a dashed line of a graphical system, that is considered not a solution. Dashed lines represent things that do not work. 2, 5, so right 2, up 5. That one is a good point. It's on the it's on the solid line and it's on the boundary of the shade. Negative 1, 3, left 1, up 3, barely falls inside the shade, but it still falls in the shade. 1, 0, over 1, up nothing, that is out of the shade, that's a definite no. Negative 3, 4, left 3, up 4. This falls on 2 dashed lines, definitely a no. 2, negative 2, right 2, down 2, again, out of the shade, definite no. 19, same idea. So 1, 1, right 1, up 1, in the shade, definite yes. Negative 2, 3, so left 2, up 3. It is on the boundary of the shade, and it's on 2 solid lines. That makes it a yes. Over a half and down 2, over a half, so it's about right here. And again, because it falls on that dashed line, automatic no. 0, 2, over nothing, up 2, solid line, boundary of the shade, yes. 2, 3, over 2, up 3 in the white space, definite no. 2, 1, over 2, up 1, again, falls on a dashed line, automatic no. Right 1, down 1, same thing there, falls on a dashed line, automatic no. 0, 4 is out of the shade, definite no. Let's talk about a point like this purple one. That point would be considered a no. Yes, it's on a solid line, but it doesn't boundary the shade, which makes it not a solution for this particular system.